Greetings and welcome, friends. Mr. Waddy here. We're going over last night's quest. We were talking about like geometric relationships and stuff, which was great. And we were talking about proofs and some different types of proofs. Two-column proof all the way. Represent. Here we go. Here's problem 4. It says identify the pairs of congruent angles in the figures. Okay. All right, explain how you know they are congruent. Well, this one's 90 degrees by definition of right angle. Is this 90 degrees? No, this is like not 90 degrees. How about this one? Yeah, how do I know that adds up to 90? Using segment addition postulate. Oh, man, with the correction. Thank you. It's okay. Maybe I'm intentionally like feigning ignorance for the sake of corrections on your guys' part so that you will feel more valuable. I don't know. Angle addition postulate. Look at that A. That's like an archy A. That's funny. That is not how I write A's. So let's see. So if this adds up to 90 degrees and this works by def of right angle, then I could say that those two measures are equal to each other, right? I could say basically measure of angle FGH is equal to the measure of angle WXZ. Yeah. I guess that would be like transitive property. Yeah. Or substitution. And then I could say that these angles are congruent. How so? Def of Cong. I almost forgot to write the congruence. I needed to give the equal sign its toupee. There we go. So def of Cong. So here we go. There's question 4. Let's keep rolling. Skizzers. Use the diagram and the given angle measurements to find the other 3 angles. So if the measure of angle 3 is 159 degrees, you'll notice that the other questions in this batch had non-simultaneously true statements to this. So there you go there. Yeah, that could be absolutely confusing. So I'm going to say measure of angle 1 is equal to 159. Why is that true? Vertical angles congruence theorem, but we will forever call it that. Excellent. Vertical angles theorem. Also, if my acronyms are unhelpful to you, it might make sense for you to write out the theorem names a little bit more until you get used to them. Until you get on the cool nickname basis like I have with the theorems, because we go way back. So that's 159. Measure of angle 4, how could I, is going to be what? 21 degrees? Yeah, that seems right. Why is that true? Linear pair postulate says they're supplementary, and then like def of sup. Right, I'd be able to say that, 159 plus that equals 180. And then using subtraction property, I'd be able to subtract the 159 from both sides. Right, so that's kind of like all of the reasons there. And then I could do the same thing for angle 2 or do vertical angles from 4. Multiple ways to get that, but measure of angle 2 is also 21 degrees for either these reasons or these reasons. Right, man. Don't undo the degree. Ah, here we go. Here's a classic. Did we do one problem like this yesterday? I don't remember. Maybe not. Now, the trick to doing these problems is to compare like things to like things. So I don't necessarily go into this assuming I'm going to use vertical angles or that I'm going to use linear pair postulate. I decide that once I realize where my x's and y's are. So here's a statement written in terms of x. Here is a statement written in terms of x. I'm going to relate those two things rather than this angle and this angle, which I could write a relationship about, but that would have x's and y's, and I would be making a system of equations which is solvable by us, but with a little bit more work. So as a mathematician, as an efficiently lazy person, let's do it the easy way. So I'm going to say 10x minus 4 is equal to 6 parentheses x plus 2. And basically that's vertical angles theorem, def of Cong, transitive property. And then I could distribute and solve. So 10x minus 4 equals 6x plus 12. There's a problem like this on the test tomorrow, by the way. Good times, good times. Subtract 6x. Fortunately, most of it's just like, the geometry shows up in step 1, and then the rest is just like good old algebra. La 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 la. Here is my algebra theme song. I don't know what, it probably has a tune from something subliminally in my head. X equals 4 by the looks of it. And fortunately, thank you, Libro. Actually, calling my book my Libro sounds pretty awesome because it's like calling it bro, except Libro is Spanish for book. But why am I happy? Because I don't have to plug this back in to find the angle measure. I just needed to find the value of x. And then similarly, I could compare, I labeled this with a double arc in blue. Yeah, I could solve for y using a linear pair postulate, but why not just compare y's to y's using another vertical angle theorem? 16y equals 18y minus 18. I do compare algebra to like karate sometimes there, and so like with the kicks and the punches and the blocks, and like you'll have to listen to some of my algebra playlist videos if you want. Nah, I just like subtraction property of equality. Like I'm teaching you, all right, that's how you like punch, 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 and then like this problem combines multiple moves. And eventually I just throw algebra problems at my students like they're a pack of ninjas that are attacking them. And then they have to like combine all of their moves to like get the variable by itself. It's pretty great. So let's see. Divide both sides by -2. I keep reminding my Algebra 1 students of that. You guys know that you wouldn't add 2 to both sides there because it's being multiplied by -2. You guys are your experts. You're black belt algebraticians. So I get y equals 9 there. So you're probably pretty good at that problem. And now for the proofs. All right, let's see. It says angle ABD is a right angle. Angle ABD is right there. And CBE is also a right angle. All right, so I've got like kind of nested right angles there. Even if we didn't have this route that we're taking here using some of our new theorems, I could have seen like an angle addition postulate. I could have seen like a reflexive property regarding this angle and like subtracting that from both sides of the complementary angles. But I don't think I even need to do that. So let's see. Let's fill this in. Why are these things right angles? Given. Right? That's the, you told me so, right? That's why. And let's see. This one's kind of nice how they like, pretty suggestive, like they tell us what, you know, almost what reason 3 is going to be. But let's see. These two are complementary, A, B, C, and CBD, by definition of complementary angles. Right? Okay. So yeah, these two angles are complementary, like so. And why would these two angles be complementary? Probably the same reason. That's probably a great reason. And then these two angles are complementary to the same angle, therefore they are congruent to each other. No. Congruent complements. You'd need some more steps to make that work. Let's see. What was it? Congruent complements theorem? Is that what it was called? Yeah. Let's see. Sorry, what was your question, Liam? Not without additional steps. Let's see. Let me make sure I got the name on this one right. Yeah, congruent complements theorem, right. And then there's also congruent supplements theorem. The idea is that if these two angles are complementary to the same angle, then they must be congruent to one another. That's the gist of that theorem. Also, your book calls that theorem 2.5, but those named or numbered names for these theorems are completely only going to be consistent within this text. So if you say, hey, theorem 2.5, when you're on the street doing geometry proofs like you do, no one else will know what you're talking about unless they're like, hey, you read Big Ideas by Ron Larson too? And then like you'll become best friends forever. But other than that, by outdoor what? I have actually just gotten into audiobooks this last couple months, and it has been wonderful. And this week, I don't have an audiobook. I have to wait until Friday to get my like free little thing part of the subscription, but I'm sad. So yes, it is brought to you by audible.com. Question 20. Oh wait, rewind. Why did I leave space here? Because I was supposed to write a flowchart proof. So let's see. Angle ABC is right. Reason given. All right. I'm going to make these two separate branches. Angle CBE is right. All right. I think I gave you guys some space to do this on your paper as well. But I didn't pre-build the flowchart. All right. This then leads to the fact that right angle ABC and CBD are complementary. Comp. Right. And similarly, right, man, I'm writing so sloppy, but it don't even matter. DBE and angle CBD are comp. Right, so these are like two branches, and I'm going to bring them together in a minute. It's going to be good. The reason these were true was def comp. Right. Right, so when I'm writing a flowchart proof, my givens are two kind of starting points, and then I'm going to bring these together here. So these were both of these statements were required to make the final statement that angle ABC was congruent to angle DB. Well, here we go. DBE. And that was true by congruent complements theorem. Right. Flowchart. I like it. I like it a lot. Now, I think it's helpful that the book has us write these proofs in both forms, so you can kind of get this concept first in the 2-column, and then maybe you could arrange your flowchart proof. Eventually, it might be valuable to be able to write a flowchart proof from scratch, but nonetheless, I believe I have a fill-in-the-blank flowchart proof on the test. Look at that. Yeah. So, all right, let's look at 20 and then move on. I've managed to fit it all on one screen. Proving a theorem. Copy and complete the 2-column proof. Did it for the congruent supplements theorem, the CST. So let's see. These are all true by given. All right, these add up to 180. Why is that true? Yeah, def of sup. Right, which also is how you would greet your math buddies on the street. You'd just say, hey, sup, right? And then like they'd be like, I know what you're talking about. Add to 180. And you're like, oh yeah, I know. So great. Let's see. How could I use the transitive property with any of the previous statements? Right? These two things are equal to 180. 180 is equal to those two things. Therefore, these must equal one another. I like it. All right. Then they said measure of angle 1 is equal to measure of angle 4. Def of pulling from here. Okay. I was going to say, I was like, how did that get from here? I was like, I can't subtract one of those things. Yeah. All right. And, using substitution, how would this help me? If measure of angle 1 is equal to measure of angle 4, I'd be able to plug it in. Indeed, indeed. So measure of angle 3 plus measure of angle 1. And now, how could I get from here to here? Subtracting measure of angle 1 from both sides. Subbed prop equal. Man, I like this. I like this. I feel like we're getting it. And the last statement should be the thing that we set out to prove, right, Ryan? That's what he said. Def of Cong. Have a great day, internet friends. We're gonna be okay.